What is solubility? Solubility is the amount of solute that can be dissolved in a solvent. That is solubility. And that can be completely dissolved in a solvent, right? As you can see here, we are taking a solute and we are adding it into a solvent. If it get completely soluble, making a solution, that means it has high solubility. Okay. So what factors the solubility depend? Both on the nature of solute and solvent, what type of solute we are using, what type of solvent we are using. Here the concept comes for like dissolve like, okay, like dissolves like, okay. Polar solvents, or say polar dissolve polar, and non-polar solute is dissolved in non-polar solvent. All right. So here comes the concept of like dissolve like. That means depending on the nature of solute and solvent, solubility depends, right? So solubility of substance varies with the change in temperature and pressure. How? If we are, say this is sugar, okay, and this is water, and here we are having sugar solution, okay. If we apply temperature to this solution, okay, if we are heating sugar and water, what will happen? The solubility rate increases or no? Tell me. Solubility increases or no? Yes, it will increase, right? So with the increase in temperature, the solubility increases. All right. So solubility varies, okay, with the change in temperature, right? So last point is here as given. Polar solute dissolves in polar solvent like sugar and salt. Non-polar dissolved in sugar. Non-polar solvent such as naphthalene or anthracene, they are dissolved in benzene only. Okay, these cannot be dissolved in water. So it depends on the nature of the solute and the solvent that we are using. So here comes the concept of like dissolve like. So I hope you understood the concept of solubility. This is nothing, the maximum amount of solvent of solute that can be dissolved in sugar. One more thing comes here, saturated solution and non-saturated solution. Many a times this question has been asked that what are saturated and non-saturated solutions, right? So saturated solution, let's see the next slide. Here we are having a definition for saturated and unsaturated solution, say non-saturated solution and supersaturated solution. So what are saturated solution? In which no more solute can be dissolved in a given solvent, right? And in unsaturated solution, we can dissolve more solute at a given temperature. But in supersaturated solution, it contains more solute that can be dissolved at given temperature. Let's say that 25% solute is dissolved in 75% of solvent. Okay. In here, say 50% of solute is being dissolved in 50% of solvent. Let's say here 70% of solute is being dissolved in 30% of solvent, right? So these are saturated, unsaturated, and supersaturated solution where we cannot add. See, take an example. This is a jar and we are having liquid here and we are adding sugar in this. Okay. There is at some moment the point comes like sugar is not dissolving in this much of solvent, right? So this will become a saturated solution. What happened at some point we are keeping, we are adding sugar to this solution. We keep on adding the sugar, but at some point, a point will come at some time that sugar it stop dissolving. That point is known as saturated solution. Okay, so what we do, we add more solution, more solvent, and then it started getting dissolved, right? So by this percentage, I hope you can understand what is saturated, unsaturated, and supersaturated solution, right? So mainly the definition, were asked in the exam mainly about what are saturated solution and unsaturated solution, right? So let's move on to the next topic, that is solubility of solid in a liquid, that we have just discussed. See, this is solid and this is liquid. On what factor it will depend? It is directly proportional to the temperature, right? As you can see here, the more we will provide temperature, the more easily the solid will soluble or solid will dissolve in liquid. All right. If the dissociation process is endothermic, the solubility of solid in liquid increases. Now what this means? Endothermic means endothermic means heat is absorbed. Heat is absorbed. If we are giving heat, obviously to a solution, the solubility of solid increases, right? And exothermic is where heat is released, so the solubility will decrease. All right. So what is the effect of pressure? This is the effect of temperature. What is the effect of pressure? As they are compressible, so solid and liquid, they remains unaffected by pressure. Right? So here comes the Lee-Chartrell principle, that is very, very important. Lee-Chartrell principle, it states that at equilibrium, what is an equilibrium? It's a static state, okay, and it will tend a net response, that means no change in the direction, whether you apply any pressure or temperature. There one point arises in solubility of solid. Say this is solid in liquid. One point arises when you are giving temperature and pressure, but no change is occurring in the state of solubility. That state of equilibrium is given by Lee-Chartrell, right? Right. So let us quickly look over to the next topic, that is solubility of gas in the liquid. I think which will be the last topic for today. Solubility of gas in liquid, where we are dissolving gas in a liquid. Can you give an example for this? For gas in a liquid. Gas in a liquid, that is Coke. Coke is liquid, and what gas is present in it? Carbon dioxide gas, that is mainly present in it. As you can see, sometimes what happens when we buy a bottle of Coke, right? The pressure is so high, right? When we just open the cap of Coke bottle, the pressure is so high. But if we kept the bottle, open for some time, the what will happen to the Coke? The taste changes, right? And the gas present in Coke, it all just flowed away. It just there there is no gas remain in the Coke if we left it open for some time, right? There we are going to, that is why we are going to study about solubility of gas in liquid. There comes a very important law, that is Henry's law, okay, which state the partial pressure of gas is the vapor phase, that is P, which is proportional to the mole fraction. The Henry's law, it is been asked in the exam very often. What is actually Henry law? I'm writing it here. It states that partial or vapor pressure, or say partial pressure of a gas, is directly proportional to the molar or say mole fraction of a gas. If we remove this proportion, if we remove this proportionality sign, we can write it as KH into mole fraction, where this represents Henry's constant. This is Henry's law. Why we study Henry's law? To know about the solubility of gas in a liquid, right? So according to Henry's law, C, more pressure present in the Coke bottle, right? If we can take an example, more will be the solubility. All right. For example, Coke bottle. Okay, more pressure is present there, more will be the solubility of gas in a liquid. Otherwise, it will become the taste. You know how it tastes when there is no gas present in Coke, right? This is Henry's law. Let us quickly see here the effect of temperature according to Lee-Chatelier principle. That is why I have discussed Lee-Chatelier principle first. That is proportional to the mole fraction of a gas. Okay. So what is the effect of temperature? The solubility of liquid decreases if we apply temperature. If we apply temperature to the Coke bottle, obviously the gas present in the Coke or say in the liquid, the solubility of gas will decrease, right? And if we apply pressure, it is an inverse relation. Okay. For partial pressures, solubility is having inverse relation. It will increase. Say Henry's constant. Okay, so I hope Henry's law is clear to you all. Let me just revise this again. What is Henry's law? It is the vapor pressure of gas is proportional, directly proportional to the mole fraction of a gas. Okay, where x here x is the mole fraction, and p is the partial pressure. If we remove this proportionality sign, directly proportional sign, we can use here Kh, which is the Henry's law constant. What is the effect of temperature and pressure of solubility of gas in a liquid? It is, if we increase the temperature, solubility of gas in liquid decreases. If we increase pressure, solubility of gas in liquid, it increases, right? Where we apply Henry's law, as I told you, when soda cans are packed, you know, so soda water bottles, they are put under more pressure to make CO2 more soluble. Okay, and you can read these applications of Henry's law in real life.